1.13. An early model for an atom considered it to have a positively charged point nucleus of charge Ze, surrounded by uniform density of negative charge up to a radius r. The atom as a whole is neutral. For this model, what is the electric field at a distance r from the nucleus? Okay, first we'll try to visualize the question. Point charge Z is at the center and negative charges are equally distributed at the surrounding. Overall, atom is neutral because at the center plus Z, surrounding minus Z, total charge is 0. What is the question? We have to find electric field in the small sphere here as well as outer sphere. Outer sphere is not shown in the diagram. First step, we will find out what is volume charge density. Volume charge density is defined as total charge per volume minus the charge is located throughout the sphere. Therefore, minus Z is located in 4 by 3 pi r cube. How many charges are located in unit volume? That is called volume charge density, volume per area. We got this. Now, next is we have to find the field in two regions. First region is R is less than R, where we have to find this is the Gaussian surface. Let us take this is the Gaussian surface. Here we have to find the electric field. Rho equal to minus ZD by 4 by 3 pi r cube. We got the volume charge density. Now, what is the volume of this small sphere? Volume of the small sphere is 4 by 3 pi r cube. This is radius is r. So, ये portion का volume 4 by 3 pi r cube. Now, how many negative charges are there in small volume? Entire sphere volume minus Z is located. Now, I want to find out how many charges are there only in the small sphere. That is, charge negative equal to rho. Rho is charge per unit volume multiplied by required volume. I repeat, what is volume charge density? Negative charge per unit volume we already calculated. Multiply with required volume. Then you are getting how many negative charges are there in the small sphere. Then, coming to the second point, what is the total charge in this sphere, inner sphere? These many negative charges are there. So, what will be the total charge? Total charge is equal to negative charge plus Z. Z is at the center, already there positive charge, plus we calculated how many negative charges are there. That is Z plus minus Z by 4 by 3 pi r cube multiplied by 4 by 3 pi r cube. So we got the total charge. Now, how to proceed? Now, how to find out electric field? We got total charge? Yes. Next step is we have to apply Gaussian theorem. Integral E dot dA equal to 1 by epsilon naught times the total charge. E dot dA becomes E dA because cos theta becomes 0. For theta equal to 0, so cos 0 value is 1. Electric field, area vector, both are on the same line. Now, which dA we have to find out? Which is our Gaussian surface? This is our Gaussian surface. So, area of this surface is 4 pi r square into Q equal to Q epsilon naught by Q enclosed by epsilon naught into 4 pi r square 1 by epsilon naught Q enclosed. Q enclosed, how many charges are there in this sphere? That is negative charge as well as positive charge. We already found out. We'll substitute this value. This gives the total charge present inside the Gaussian surface. Inside the Gaussian surface, these many charges are there. So, E becomes 4 pi r square. You have to divide 1 by 4 pi epsilon naught r square into Z plus of minus Z by 4 pi 3 pi r cube into 4 pi 3 pi r cube. Okay. Now, we'll go for the second part of the question. That is, what's the second part of the question? How many charges are there outside? We have to find out electric field outside now. Let us take point P here. The distance from center to P is small letter r. That is, R value becomes greater than capital R. So we have to imagine a Gaussian surface through this portion now. Okay, through this point we are imagining a Gaussian surface. What is the total charge now? Our Gaussian surface is outside. It contains all positive as well as negative charges. We already discussed that atom is neutral. Therefore, plus Z plus minus Z, total charge becomes zero. If total charge is zero, electric field is zero because E into 4 pi r square, 1 by epsilon naught times the charge, total charge equal to zero. Therefore, electric field equal to zero.